Hey guys, this is Murtaza from Networkers Home. Welcome back again to another video. And in this video, we'll be seeing the lab of Get VPN. First of all, let me tell you something about Get VPN. I'll tell you some key features about Get VPN. First of all, it allows us to encrypt data traffic on private WAN like MPLS or Metro 800. So it requires that we have full routing established. If I'll talk about this topology, I should have a full reachability end to end in order to do the configuration of the Get VPN. So I can say this is more efficient in terms of encryption, as it does not take care of the routing, because I don't have to care about routing. In DMVPN, we had to take care about the routing as well, but in Get VPN, we are not concerned about the routing, because that should be established before doing the Get VPN, and that is the concern of ISP basically. Because if you're going via the service provider, you're taking his service like MPLS or whatever service he's providing. So that's not your headache to look after the routing. But yeah, you should be able to ping from one side to another. But you only have to do the Get VPN configuration, and the rest routing part has to be done by the service provider itself with the help of MPLS or whichever WAN technology he will use. So what is the benefit of using Get VPN? In Get VPN, we have a centralized mechanism of setting up IPsec. So what we do here is that we keep one router as a key server. As I have kept this router, this is my router 3, I've named it as server. I've kept this router as my key server. So this key server is responsible for configuring all the transform sets, ACLs, and session keys. And then these parameters are pushed down to the encrypting routers. And these routers are known as group members. So if this is my key server, the rest of these, I can say, routers or encrypting routers are my group members. So these are called group members, and this is my key server. All these parameters, there is transform set, ACL, and session keys. I'll create those three things on the server only, and then I'll push those parameters to my group members. So in phase one of IPsec, normal IPsec, and in phase one of this Get VPN, the difference over here is that it uses phase one to push session keys to the group members. But the protocol that is used in phase one is a variation of ISACMP protocol, because ISACMP only exchanges the session key, and the protocol used to exchange the session key, transform set, and ACL here in Get VPN, that protocol is known as Gdoi. The full form is Group Domain of Interpretation. With the help of this Gdoi protocol, in the phase one is used to push the session keys to these, I can say, group members. I'll push these parameters, I'll push these keys from the server to these group members. But make sure you don't get confused that the key server cannot be used for encrypting the data. It will just push the parameters, that is transform set, ACL, and session keys. It has nothing to do with encryption. So you don't have to create any ACLs, transform sets, or session keys on your group members. That will be pushed by the server itself. Rest, the encryption has to be done on clients that I mentioned here. These are my group members. And this GDOI protocol works on UDP 848. So my overall point is the key server will have a phase one with all the GMs. So my server over here will have phase one with client 1, client 5, and client 6. So the GMs that are my group members are only going to have phase 2 with each other to transmit data encrypted using the key from the key server. These client, for example, this client 1 and client 5 and client 6, they will have phase 2 with each other to transmit the data in an encrypted manner using the key that they will get from this server itself. So make sure you don't get confused that the server does the encryption. It does not. So the prerequisite of this Get VPN lab is you should have full reachability prior to the setting up of Get VPN. So let's not discuss more theory. That's, I guess, enough for you to understand the key features of Get VPN and why do we want Get VPN. So let's jump right into the configuration. So I have configured the IP addresses and the loopbacks that I'll be using for the testing purpose that I'll define in my interesting traffic. So all the reachability is already verified. I'll check once again. And the IP addresses are and the routing protocol are done according to what I have shown in this topology. I mentioned this topology. I'll go on client 1 and I'll try to ping from loopback 10.1.1.1 to loopback 1.1.6 and 1.1.5. That's how we'll verify our connectivity from end to end. I'll go on client 1 and I'll say ping 10.1.6.6, source loopback as 10.10.1. You can see I have a reachability from client 1 to client 6. And let's try from client 1 to client 5. Source as my, you can see I have the reachability from client 1 to both the clients, 5 and what is it? It's 6. Now I'll check the reachability from 5 to 6. Or I can say, this is my loopback 0, I guess. Oh, sorry. Why is it showing? Okay, let's do one thing. Yeah, I have the full reachability from client 5 to client 6 as well. So what we'll do, I'll go on the server. This is my server where I'll create the phase 1. I'll create the transform set, the ACLs, and the phase 1 parameters. And then I'll push those parameters to my group members. So first of all, let me take a notepad. That's a good thing. Let me take a notepad. Let's type here. I'll say crypto ISA camp policy 10. First of all, I'll define my hashing algorithm, that is MD5. Authentication, that is pre-share. My group will be 2. Life you don't need to define, but you can define, it's optional. And last but not least, encryption, that is AES. Now I'll define the key. Crypto ISAChem key. Let's keep it to Cisco. Let's keep it as Cisco 111 address. Now, pay attention here. I've got 1, 2, and 3. These are my 3 GMs. That is my group members, or you can say clients. So if I want, I can create 3 keys for 3 different group members. That is, for example, I'll show you. This is my first client 1. I can say 192.168.12.1. You can see that is the IP address of client 1's E00 by 0 interface. And then for these 5 clients, 5 and 3 is 6 client, I have to write like this. Let me show you. So this will be something on 45.5 and this will be 46.6. So either you can do it like this, or I have a simple way to do this. Put the address as 000, match all. So even if you have multiple, for example, if you have 10 group members and a key server, you don't need to mention each and every group member's IP address over here to define the key. So rather than doing that, it's up to you. You can do it like this, define 000, so it will match every address, or you can define statically, manually, those 10 IP addresses for the particular keys. So that's my suggestion to you. Not suggestion, but that's how I am doing it right now, so that it cannot, so that I won't make it difficult for you. This is my phase 1. Let me write it down. So now I need to configure phase 2 parameters. I'll say crypto IPsec transform set. I'll name it as set, or let's keep it, okay, let's name it as tset. It is case sensitive. And I'll say ESP, AES, ESP, SHA, HMAC. Now, my third thing that I have to do, I have to configure the ACL. So I'll define the ACL, access list 100, permit IP. So my intrastic traffic will be from 10.1.1.1 to 10.1.1.5, 10.1.1.1 to 10.1.1.66, or from 10.1.1.5 to this loop back, or from this loop back to this loop back. So there is a trick I have applied here. For your convenience or for your ease, this won't be the real scenario. It's just for the lab purpose. You won't get such kind of IP addresses in the real time. You can get, but that's a rare case. What I've done here, I have configured the loopback in such a way that it will be easier for me to write the interesting traffic in the ACL. For example, I've written 10.1.1.1. So when I'll write my ACL, I'll write it like this. Access list 10 IP 10.1.0.0 to destination 10.1.0.0. So you can check my ACL. I've defined the interesting traffic. This is from 10.1.1.10.1.0.0 to 10.1.1.0.0. So it will match each and every traffic from here to client 6, from 5 to 1, from client 5 to client 6. So this is a trick. This is just for the lab practice. You won't necessarily get in this in your corporate network. Now, the fourth thing that I have to do is configure IPsec profile and then attach the transform set. Wait. So that's, let me do one thing. I'll should write like this. This is my first. Let me put it as 2. This is 3. This is 4. So I'll create a profile, crypto IPsec profile. I'll name it as prof, and I'll attach my transform set transform set, that is tset, as I have configured here, tset. Now another step, that is step number 5, is I have to configure Gdoi. That is my group domain of interpretations. I'll say crypto Gdoi group. Let's name it anything 1, or you can name it as ABC, whatever you want to call it. Identity. Identity number. Let's name it as 1. So local. The server is local. ISA. These are my IPsec parameters. This is a sequence number for the IPsec essays, and then I'll attach my profile, that is named as prof. I'll match my ACL as well. There is, I guess, 100. Let me check. Yeah. So I've created a group, GDOI group, with the help of command crypto GDOI group named as ABC, identity number 1. So anytime any group member with the identity 1 will reach to server, these parameters will be pushed to that particular client with this identity number. So, and the last but not least, that is the IP address of the server, P server itself. IP address IPv4, and I'll put it as 3333. So that's all the configuration for the group, for the server, for the key server. Let me recap. First of all, I created my phase 1. This is my ISACM policy 10. I have configured the hashing algorithm as MD5. Authentication is pre-shared. Group is 2. Life is optional. You want to keep it or you're not. It's up to you. Encryption is AES. Then I have configured the key, the crypto key, for each and every group members whosoever wants these parameters. For that, I have defined 0000. Else you can define manually for all these group members. Then my second task was to configure phase 2, crypto IPsec transform set, preset, and the parameters. And those parameters for the phase 2 is ESP with AES and ESP with SHA-HMAC. The third task I had to do was configure the ACL, that define the interesting traffic that I'll push to the group members. This is from 10.1.0.0 to 10.1.0.0, so it will match the traffic. I don't have to create 4 to 5 ACLs for these traffics. From 1 to 5, from 1 to 3, sorry, 1 to 6, 6 to 1, 6 to 5. So it was a heck to create so much ACLs. So that's why I did such a configuration. I did such a configuration of loopbacks, and with the help of those configurations, though that smart IP address assignment, I have created this ACL. The fourth step was configure IPsec. I've configured IPsec profile, and then I attached the transform set to that profile. I created a profile with the name of prof. I've attached my transform set that is named as tset over here. Then I configure a GDOI group. with the name of ABC. I define the identity number 1. So that any group member with the identity number 1 will be given, the key server will push these parameters to that group member. This is the local server. This is my Ipsec essays. I've attached my profile with the name of prof. This is the IP address. This is the ACL defined here. I've matched the ACL with the ACL number of 100. And last but not least, this is my IP address of the key server. So I'll go and paste it on my key server. This is my key server. I'll paste it down. I guess something is wrong. Okay. Here. This is crypto IPsec profile. Let's paste it again. I'll go on the server. You can see the crypto Gdoi is on. Now I'll be configuring these group members. I don't have to create any ACL. I don't have to create any transform set. I don't have to define the interesting traffic. I just have to configure phase one for client 1, client 6, and client 5. So this phase 1 will be for client 1 and server, client 5 and server, and client 6 and server, so that they can download, I can say download, so that the server can push these parameters that I've configured here for these group members. And then they'll do the encryption. I'll show that in a minute. So let's configure the first client, that is client 1. Let me take a notepad again. This is my notepad. Now on my client 1, this is my client 1. The first thing that I have to do is, my first task is to create a phase 1. I'll do it fast. I don't need to write the whole word. Either you can write it like this, or you can short it down to PO. Crypto ICCAM policy 10. My hash is MD5. You need to match this parameters, so that you need to match these parameters, the phase 1 parameters, with the key server. If it is mismatched, you won't be able to see the ACLs, transform sets, and the interesting traffic on your client 1. So what I'll do, I'll copy this phase 1 from my group's key server like this. It has to be same, but make sure you don't mention here 000. You mention the IP address of the key server itself, because I want to do the phase 1 with this key server only. Now I need to tell my third task is, sorry, my second task. I need to configure Gdoi group, so that I can tell the group server to which identity I belong. I'll say identity number 1 that I mentioned here. It should be same. Identity number 1 and the server address IPv4, that is 3.3.3.3. Now, my third task. My third task is to configure crypto map, crypto map. I'll say, sorry, crypto map C map. Define the sequence number 5 and name it as GDOI. Let's name it as GDOI. You can name it anything you want. I've named it as GDOI. Sorry. You can name the crypto map as whatever you want, but I have named it as crypto map, and this is the command. I'm sorry. This is GDOI. I'll attach my GDOI group to my crypto map. I'll say set group and the group name as GDOI that I have defined over here. Okay, I have missed a command, I guess, because I wrote to configure a group, GDOI group, but I haven't configured one. This is crypto GDOI group, and the name will be, let's give it the name GDOI 1. Yeah, good. So I've attached this GDOI group to my crypto map. And now the last task, the last step is fourth, that is apply it to outgoing interface. So I'll go under the particular interface, interface E0/0, that is this interface, and I'll say crypto map CMap. That's it. So let's check once again. These are my phase 1 parameters. I have copied the same from the key server configuration because it has to be same. And crypto Ipsec key Cisco 111, address of the key server. Crypto, I'll create a GDOI group with the name of GDOI_1. The identity is 1. And the server IP address is 3.3.3. Now I have attached this GDOI group under a crypto map. I've created a crypto map with the name of CMap, and I've attached this crypto map over here because we cannot, not me, we cannot attach this GDOI group directly under an interface. So for that I have created a crypto map, and I have attached this GDOI group under a crypto map, and then I have attached this crypto map under the particular interface that is my outgoing interface. So I'll go on my client 1 over here. I'll copy and paste. Now you can see it has started a registration to the key server with the IP address of 3.3.3. This is your GDOI group name. And you can see registration complete, and you can see here success. So if I'll go on my key server, I'll say do show crypto do show crypto GDOI KS members. You can see the first member, my group member, that is client 1 with the IP address of 12.1. It has successfully registered. Now I'll do the same on the rest of my clients, my group members. The only difference, I'll show you the only difference. This will be my client 5. The phase 1 will be same. The key will be same. GDOI group will be same. Nothing will be changed except the outgoing interface. In my case, even that's not different. E0/0, E0/0 on both the clients and on the client 1 as well. So in case in your case it can be different, but in my case it's same. So everything is same. I'll copy and paste it on client 5. I'll go on client 5. I'll copy and paste. You can see started registration to key server 3.3.3 and the success. And same I'll do on my client 6. Okay. Now we have to wait for that. So till then we can check. Another group member has successfully registered. You can see. Let's see if client 6. Okay, yeah. Copy and paste. Okay, I have to copy again. Let's wait. Success. Let's go on key server. You can see 3 group members have successfully registered. Now I'll go on my client 1. Do show crypto IPSA ISACAMP SA. You can see active. This is the source. And then do show crypto IPSA. The local identity is 10.1.0.0 and the remote is 10.1.1.0. So you can see the transform set downloaded from the server, ESP AES, ESP SHA-HMAC. This is the SPI, and okay, you can see here the lifetime 3368. So whatever the lifetime will be on the server, that will be same on these group members. Now I'll try to ping from client 1. Do ping 10.1.6.6 and the source will be 10.1.1.1. You can see I'm able to ping. Let's check whether the traffic is passing through the passing encrypted. Yeah, you can see packets encrypted and packets decrypted. Let's check the connectivity between client 5 and client 6. I'll say do show crypto IPSA. Now I'll try to ping. If you'll see the transform set ESP AES, SHA-HMAC, and the SPI, it is same. That is downloaded from the key server itself. You don't have to do any configurations on this client. So I'll try to ping from 10.1.5.5 to the source of 10.1.6.6. Okay, sorry, vice versa. 6.6 to source 10.1.6. 5.5. Now if I'll check IPSA, you can see 5 packets. Now if I'll try again, now you can see 10 packets. So my packets are going encrypted. From here, the packets are being encrypted, passing through R4 server, R2, and reaching to R1, and then it gets decrypted over here, there. So if later in your corporate network you'll connect another client or a group member, you don't need to do any you don't need to configure any transform sets, ACLs, or any keys. You just need to connect it. You just need to do the phase 1 with the server itself. It will download those parameters from the server, and the rest configuration I have shown you. So it is a very scalable. I cannot say very scalable, but it is scalable than MGRE and DMVPN because you don't need, you are not worried about the routing. You're just worried about the data traffic. So that's how you configure the Get VPN. I hope you understood everything. I hope you like this video. I'll see you in the next one.